Alright, this section is on isosceles triangles and their theorems. It's section 4.4 in your geometry textbook. And I know we've already talked a little bit about isosceles triangles before, but we're going to talk about some official theorems when we get into these things. So first, let's recall the parts of an isosceles triangle. Those parts include the two legs, which are the congruent sides, and a vertex, which is where those two congruent legs meet, a base, which is the non-leg side, and then there's two base angles. Now, Theorem 4.1 says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So angle opposite means we go across. So angle 1 is opposite that side, angle 2 is opposite that side. And that means those are the ones that are congruent. So basically what we're saying is the base angles of an isosceles triangle are congruent. Some corollaries based off of that. First, an equiangular triangle is also equilateral, meaning if the angles are all equal in a triangle, then all the sides are equal, which you probably already knew. And an equiangular triangle has 360-degree angles. We also knew that because that's an equilateral triangle. And corollary 3 says the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. And we're going to explore corollary 3 right here. This is what corollary 3 said. And that means if we take an isosceles triangle and we draw a bisector of the vertex, so we're going to bisect the vertex right here. And a bisector, remember, splits the angle in half, so we've got two equal parts right here. And it slices the triangle into two congruent triangles. Do you see the two congruent triangles? By side, angle, side. So we've just sliced this right down the middle into two equal triangles. Oops, I'll let you see this guy. So we just split that right down the middle. That's my helper. He helps me slice things up sometimes. So we've got side, angle, side. So since we have two congruent triangles, we can conclude that these two pieces are equal by CP/CTC, and these two angles were equal by CP/CTC. Well, since they're equal and they add up to 180, these angles have to each be 90. So that's why the bisector is perpendicular to the base at its midpoint. Theorem 4.2 says if the angles of a triangle are congruent, then the sides opposite those angles are congruent. So basically, if we have two angles that are equal, then we have an isosceles triangle. Sides opposite must be congruent. Here are some examples. So if we're asked to find x in this first triangle, we might say, okay, these two sides are equal, which means these two angles are equal. So this angle right here is going to be x also. And that means we can say x plus x plus 30, oh, my plus got a little funky there, equals 180. And we can solve for x there. Oops. I guess that's I didn't mean to hit that there. So we get, these two are each going to be 75. Now over here we have two base angles here congruent, which means this side's not congruent to anything, so we don't even need that. It's just there to throw us off. So here we're going to have 2x minus 4 equals the x plus 5 side. So we have x equals 9er. And the last one, we have a 56 and a 62. Well, we add those together and get 118 for the two of those added together, and we subtract from 180. Oh boy, this writing instrument's not working so well. So we get 62 degrees for the last angle. which tells us that we have an isosceles triangle. If these two are equal, then they're the base angles, and the sides across from them are equal. So the 42 is equal to x. So x equals 42. That's it.